We are going to study about colloids, which is a chapter included in your text Principles of Physical and Organic. Colloid is not a substance, but it is a state of substance which depends upon the size of the types of solution. Depending on the size of the particles present in the solution, there are three types of solutions are there: true solution, colloidal solution, and suspension. Comparing the properties of true solution, colloidal solution, and suspension, the particle size of true solution is less than 1 nanometer for 1 nanometer. For colloidal solutions, it is between 1 nanometer and 100 nanometer, and for suspension, it is more than 100 nanometer. About the state, true solutions and colloidal solutions are stable, whereas suspension are unstable. And Tyndall effect is shown by colloidal solutions and suspension, whereas it is not shown by true solution because the particle size is very low for true solution. Tyndall effect is the scattering of light rays by the colloidal particles. Separation by filtration. True solutions cannot be separated by filtration. Colloidal solutions can be possible by to separate by filtration, but suspension is very easy to separate by using simple methods like filtration. About the nature, true solutions are transparent, colloidal solutions are translucent, suspensions are translucent or opaque. Phases of colloids. There are two phases of colloids: dispersed phase and dispersion medium. Dispersed phase is the component present in small amount and it is just like a solute in a solution. It is also called discontinuous phase or inner phase. It is the dispersed substance present in the colloidal solution. Dispersion medium, it is the component present in excess amount and is just like a solvent present in a solution. It is also called continuous phase or outer phase. It is the medium in which colloidal particles are present. In a colloidal solution of sulfur in water, sulfur particles constitute the dispersed phase and water constitutes the dispersion medium. Classification of colloids. There are several classifications. First one is based on the state of dispersed phase and dispersion medium. If the dispersed phase is solid and dispersion medium is also solid, the type of colloid formed is called solid sol. Example, colored glasses and gemstones. If dispersed phase is solid and dispersion medium is liquid, it is called a sol. Examples, paints, cell fluids, etc. If the dispersed phase is solid and dispersion medium is gas, it is called aerosol. Example, smoke, dust. If dispersed phase is liquid and dispersion medium is solid, the solid colloid particle formed is called a gel. Example, cheese, butter, jellies. If both the dispersed phase and dispersion medium are liquid, then it is called emulsion. Example, milk, hair cream, etc. And if dispersion medium is gas and dispersed phase is liquid, it is called aerosol. The example, fog, mist, cloud, insecticide sprays, etc. If dispersion medium is solid and dispersed phase is gas, that is gas in solid, it is called solid sol. Example, pumic stone, foam, rubber, etc. If the medium is liquid and dispersed phase is gas in liquid, it is called foam. Example, froth, piped cream, soap. Based on nature of dispersion medium, there are four types of colloids. They are hydrosol, alkosol, benzosol, and aerosol. In hydrosol, the dispersion medium is water. In alkosol, that medium is alcohol. And in benzosol, the dispersion medium is benzene. and in aerosol, dispersion medium is air. Based on the affinity or intermolecular attraction between the phases, there are two types of colloids, lyophilic colloids and lyophobic colloids. Comparing the properties of lyophilic and lyophobic colloids, lyophilic colloids are reversible in nature, whereas that of lyophobic are irreversible. Regarding the preparation, lyophilic colloids are very easy to prepare. They can be prepared by shaking or warming the substance with the dispersion medium. They do not require any electrolyte for their stabilization. Whereas lyophobic colloids are difficult to prepare, some special methods are used for their preparation. Addition of stabilizer is essential for their stability. Regarding the stability, lyophilic colloids are very stable and are not easily coagulated by adding electrolytes. But due to the unstable nature of lyophobic colloids, they get coagulated by adding the electrolyte. And charge, lyophilic colloids carry no charge regularly. Sometimes they may carry very little charge depending upon the pH of the medium, whereas lyophobic colloids always carry either positive or negative charge. Regarding the viscosity of lyophilic colloid is same as, very higher than that of the medium, whereas it is same as that of medium for lyophobic colloids. So in the same way, surface tension also very less than that of medium for lyophilic colloids, and for lyophobic colloids, surface tension is same as that of medium. Migration in electric field, the particles may or may not migrate in the electric field for lyophilic colloids, but for lyophobic colloids, the particles always migrate either towards cathode or anode by applying an electric field. In the same way, in the case of Tyndall effect also, lyophilic colloids do not show Tyndall effect, whereas lyophobic colloids always exhibit Tyndall effect. Based on charge on the colloidal particles, the colloids can be classified into two, positive and negative colloids. The salts of metal hydroxides like ferric hydroxide are usually positively charged, whereas those of metal sulfides like arsenic sulfide are negatively charged colloids. Based on molecular size, the colloids are mainly classified into three: multimolecular colloids, macromolecular colloids, and associated colloids. In the case of multimolecular colloids, the particles consist of an aggregate of atoms or small molecules with a molecular size less than 1 nanometer. Example, gold salt, sulfur salt, etc. In this case, particles are held together by weak van der Waals force of attraction. Macromolecular colloids, in this type of colloids, the particles of the dispersed phase are big enough to be of colloidal dimension. These colloids are usually polymers like starch, proteins, cellulose, polythene, etc. Regarding the last one, associated colloids, they are colloids which behave as normal strong electrolytes at low concentrations, but behave as its colloidal properties at higher concentrations due to the formation of aggregated particles. They are also known as associated colloids or miscellaneous. Example, the surface active agents like soaps and synthetic detergents. These are, this is all about today's portion. I will give you an assignment in your Google Classroom. You have to submit it within the stipulated time so that I can give you the attendance for today's class. Thank you.